Myself, Dr. Santosh Kumar Chaudhary. Today I will discuss about delta to star conversion. Here we have like delta to star conversion we are trying to do. Here what we have to means, first of all we will have to take one delta. Like that. So here what happened? Suppose we have some value, like here we are assuming R1, this is R2 and this is R3. Here we are suppose assuming A, B and C. Now here as we are trying to convert from delta to star, obviously we will have to take some resistance like that here, here and here, like that. Now here we are assuming suppose RA, RB and this is RC. So if you see here separate star, now this delta will be looking like in a star like that. This is B, A and C. So here we have like this resistance value is nothing but RC, this resistance value is RA and this resistance value suppose RB. Now as we are converting from delta to star, we will have to calculate the value of RA, RB and RC. Here what we are doing means, when we are trying to convert from delta to star, then here when we are trying to find the value of RA from here, so what we will have to do means, simply we will have to multiply R1 multiply R2 by sum of the all resistance, that is nothing but R1 plus R2 plus R3. Like here we have R1, R2, R3, so here we are simply adding R1 plus R2 plus R3 like that. Similarly, when you are trying to calculate the value of RB here, so what we will have to means, here R1 multiplication of R3, so here we are doing R1 multiply with R3 by R1 plus R2 plus R3. Similarly, when you are trying to calculate the value of RC, now in RC, R2 multiply with R3, R2 multiply with R3 by R1 plus R2 plus R3. Like that. So here what will happen now, this delta will be easily converted into a star, and after that we can try to means take the equivalent resistance. Similarly, here we are trying to convert from a star to delta. So now we are trying to convert from a star to delta. In a star to delta, what we will have to do means, here again we have one star connection, like that we have. Here this terminal we are assuming A, B and C. So this resistance value suppose RA, this resistance value is RB and this is RC. Now what is our target? Our target is to convert star to delta. So obviously the delta will be like this is C point, this is A point and this is suppose B point. So A to C, now here we will have to connect. Here we will have to connect one resistance like that. And to assume like here suppose R2 we are assuming, and here one resistance we'll have to connect like that. So here R1 assuming, and B to C again we'll have to connect one resistance, that is called as R3 suppose. So here what we are doing is like that A to C we are adding one resistance, like you may say that R2, and here we have like one resistance, this is nothing but R3, and this A to B we are adding one resistance like R1. Now again here also, as we are converting from star to delta, so again we will have to calculate the value of R2, R1 and R3 and R3. Now when we are trying to calculate the value of R1, R2, R3, this unknown resistance value, as we have converted from star to delta. So here what we are doing is, here first of all suppose we are trying to calculate the value of R1. So what we have to do means, here we will have to multiply these two resistance plus again these two resistance we will have to multiply plus again these two resistance we will have to multiply. So when you are talking about R1, so what we are doing, R1 means we are trying to find, so here what we will have to means R1 RA into RB plus again these two resistance we will have to multiply, so RA into RC plus RC into RB by, as we are trying to calculate the value of R1, so here simply we are multiplying these two resistance, again we are adding with these two resistance and again these two resistance by, see when we are trying to calculate the value of R1, that means this R1 will be connected with R means point A and point B. Which one will be left? C. So this C we will have to write here, so by RC here we will have to do. Similarly, when you are trying to calculate the value of R2, so what we will have to means, here whatever procedure we have followed, same procedure we will have to follow here also. Like as we are trying to calculate the value of R2 means, again R1 into RA into RC, RA into RC plus RC into RB plus RA into RB by, as we are trying to calculate the value of R2, so if you see means this RB terminal will not match with this one, that means these two are not connected. So here what we are doing means, we are writing RB. Similarly, when we are trying to calculate the value of R3 means what? Here again we will have to follow the same procedure, like RC into RB plus RA into RB plus RA into RC by, here opposite resistance if you will see means this RA will not match means with these two node like that. So here we are writing RA. So here I have shown that when we are trying to convert from star to delta, we will have to follow this procedure, and with the help of this procedure we are able to find the value of this unknown resistance value as we are converting from star to delta. Now I am taking one example. With the help of that I will try to solve so that it will be easy, and we will have to use this property so that we can easily able to find the value of equivalent resistance. So here I am taking one example like find the equivalent resistance, find the equivalent resistance of A and B, and we have this circuit. Like that way. So here we are assuming A, B. Here we have 4 ohm resistance. This resistance value is also 4 ohm. This resistance value is 8 ohm. This is 4 ohm resistance. This is 8 ohm resistance. This is 6 ohm resistance. Now here in this circuit, directly we cannot able to use series and parallel combination. So obviously we will have to use either delta to star conversion or star to delta conversion. So here we are seeing that in this connection, if you rearrange, like means again this resistance and if we connect directly from this point to this point, means like that. So this is AB, 4 ohm resistance, 4 ohm resistance, 8 ohm resistance, and this is 4 ohm resistance, 8 ohm resistance, 6 ohm resistance. That means simply we have rearranged. Rearranged means now here we can easily able to identify that here we are getting like delta connection. So in this delta again we will have to convert from delta to star. If we will convert from delta to star, then easily we are able to find the value for equivalent resistance. So again we are rearranging, and here we will have to keep like means one resistance here, one resistance here, and one resistance here. Suppose here we are assuming like R1, here R2, here R3. So here simply what we'll do means now my circuit is like this, and here again we will have to follow the property through which we can easily able to calculate the resistance value like that. So here we have suppose R1, here we have assumed means here R3, suppose here R2 like that, and here already we have like 4 ohm resistance, 4 ohm resistance, 8 ohm resistance like that. So now we will have to follow the property through which we can easily able to calculate the value. That means here we have like R1, R2 and R3. As we know that here we just now we have derived, that means when we are trying to convert from delta to star like that. So simply we will have to use the property like here we have assumed like suppose R1, this is R1. So here we have 6, here we have 8. So R1 value we can easily able to calculate like 8 into 6 by all summation, like that means 8 plus 6 plus 4, like that. Similarly, if you want to calculate the value of R2, R2 means here we are assuming R2. So here 8 into 4, 8 into 4 by 8 plus 6 plus 4, like that. Similarly, for finding the value of R3, here we have 6 into 4, 6 into 4 by 8 plus 6 plus 4, like that. So here I have calculated directly, and we got means here 2.66 ohm resistance. Similarly, for R2 here we are getting 1.77 ohm resistance, and for R3 here we are getting 1.33 ohm resistance. So here easily I can able to write the value of R2, here R3 value, and here R1 value. So R1 value here we are getting 2.66 ohm. R2 value here we are getting 1.77 ohm resistance, and R3 value here I am getting 1.33 ohm resistance. Now here what we are doing is that again I will draw this circuit. Okay, so now here what we are doing means here we have like this resistance and 4 ohm resistance here. This is our 8 ohm resistance. After that, again we are adding 1.33 ohm resistance here, and this resistance is nothing but 2.66 ohm resistance, and this resistance again we are connecting with 1.77 ohm resistance, that is nothing but the R3. So here we have A, B, and like that. Now as we know that the value of this resistance is 4 ohm, here also 4 ohm, here 8 ohm, like that. Now these two resistances are connected in series, and similarly here also these two resistances are connected in series. So now here again we are writing like 4 ohm resistance, and here instead of 2, as these two are in series, so we will have to write like 1 ohm resistance only. So here the value will be like now 6 plus 6 ohm resistance, and here 9.33 ohm resistance, and again these two resistances will be connected with 1.77 ohm resistance. Now again here we have these two resistances are in parallel, so we will have to convert like equivalent resistance. So here we have 4 ohm resistance. Now these two resistances will be like that. So here I have calculated like as you know the property of parallel, so 6.66 into 9.33 by 6.66 plus 9.33. So here we are getting 3.88 ohm resistance. So directly here we are able to write 3.88 ohm resistance, and remaining resistance is nothing but 77 ohm resistance. So now here we can able to write the equivalent resistance RAV is nothing but 4 ohm resistance plus 3.88 ohm resistance plus 1.77 ohm resistance. So if we add all, here we are getting 9.65 ohm resistance. That is our answer. Thank you.